Welcome to the 13th video in the Metric Math, Water, Wastewater YouTube series. This video will focus on how to find the volume of complex shapes. In this case, it'll be a cylinder and a cone, but the concept would work on many other complex shapes. Now, some key background ideas that you have to keep in mind when you're going through this particular video. First of all, and I've mentioned this many times in the previous videos, read the information carefully. What's important? What are the key words? What are the numbers? What are the units that go along with it? Take your time. You're not going to get any bonus marks for getting it done quickly, but you will get penalized if you get the answer wrong. So take your time. Next thing that you have to keep in mind is the basic conversion. When you go from megaliters to cubic meters, you multiply by 1,000. Or when you're going from cubic meters to megaliters, you divide by 1,000. When you're going from cubic meters to liters, again, you multiply by 1,000. Next thing is sometimes when you have really complex or big amounts of information, it's to your advantage to make sure that you just do a simple thing like draw a picture, draw a diagram, and then make sure that you label it with numbers and their units. So that makes it a lot easier to visualize what exactly is happening in the question that you're working with. Last but not least, when you take the numbers from the picture, transfer them into your formula with the units. It's so important for you to keep track of the units in all of your math calculations, especially when you have to do a conversion from cubic meters to liters or megaliters or whatever the question is asking. Now, the question that we're going to look at says, find the total volume in megaliters, notice in megaliters, of a reservoir 35.2 meters in diameter. It has a sidewall height of 12.1 meters. At the bottom of the reservoir, the floor slopes downward an additional 1.8 meters to the sub. Okay, so that's our starting point. There's a lot of words in there. So it becomes important for you to kind of filter out the fluff and get the actual key pieces of information. Now we're going to take a look at the keywords and the numbers that go along with it. First keyword is diameter. That tells you the shape. Now we haven't even looked at any numbers, but now we know that the shape is going to be a cylinder, and it's going to be, the formula for that is going to be 0.785 times diameter times height. Now that we know that the shape is a cylinder, now we can start putting the dimensions in. The first dimension that we want to take a look at is the diameter, which is 35.2 meters. The next dimension is how tall this thing is, and the sidewall is another way of saying the height, 12.1 meters. Now, after we have got that taken care of, notice there's something else. There's at the bottom, there's another shape that's tied in with it. Now, the bottom of a cylinder that slopes in, that's called a cone. And in this particular example, the height of that cone is 1.8 meters. Last but not least, what is the final unit of the answer that we're looking for? Is it going to be liters? Is it going to be gallons? Is it going to be cubic miles? Like, what's it going to be? In this case, it's megaliters. Now that we've identified all the key words, now we can get going on the question itself. Now let's draw a diagram. We know that the diameter is 35.2 meters, so let's draw that out. We know that the sidewall is given as 12.1 meters high, so we can draw that in. And that finishes off the first shape that we're looking at. So I've just put a dotted line in there to show the bottom of that particular shape. Underneath this shape is a second shape, and notice it's a cone. And the height of this cone is approximately about 1.8 meters in height. We have to label these just to make it a little easier when we do our formulas. So let's call this top part shape 1, and it's a cylinder. The bottom one is shape 2, and it's a cone. Now that we have the diagram drawn out, labeled, numbers, units, now we can take that information and transfer it into some actual formulas. So the first formula that we're going to do is find the volume of that cylinder shape. And we know that the formula is 0.785 times diameter times height. Please make sure that you actually put the words diameter in there, and not just diameter with a 2 beside it squared. It's too easy to think of that 2 as just being diameter times 2. So write out the formula, put the words in. Now you can plug the numbers in. Okay, we know the diameter is 35.2 meters. We have to do that 2 times, and we know that the height is 12.1 meters. So now we can plug those numbers into the formula. As you go through your math, Let's just do the multiplication. Notice it's about, there's probably some rounding in there someplace, it's about 11,769, and notice the unit, it's cubic meters. The second shape that we're looking at is the cone. And we will remember that, again, the formula for a cone is 1/3 times 0.785 times diameter, height. Now, sometimes you might have some problems putting in 1/3 into your calculator. Another way to do that is just do the formula 0.785 diameter, height, and then divide by 3. Same thing. So let's put the numbers in. Diameters, as we mentioned, 35.2. The diameter of the cone is the same as the diameter of the cylinder. But now the height of the cone is 1.8 meters. So we plug those numbers into the formula, and the answer is approximately 583.59 cubic meters. Now, step 4 is we take those numbers and we add them together. The total volume is the volume that we found of the cylinder plus the volume of the cone. We take those previous answers and we plug those into the formula, add them up, and you get approximately 12,352.59 cubic meters. Now we check, did we have the right unit in the answer? So we found in the initial information that we're asked to find it in megaliter, but our answer that we just calculated was in cubic meters. So we got to do a conversion there, and remember to move the decimal 3 spots to the left when we're working from cubic meters to megaliters, or divide by 1,000, whichever one makes sense to you. Final answer is 12.35 megaliters. Thanks for watching this math video. Please check out the other videos in this series and put in some comments. Pass the site on to any other water or wastewater students that might need some assistance for it. Goodbye for now, and have a good day.